Okay, so in this lesson today, we're starting our integral unit for specialist mathematics in the Queensland system. This lesson, we're just reviewing the basic integrals that you should know from methods. Okay, so we'll look at general polynomial functions, power functions. These two pretty much have the same rule. Trig functions, looking at sine and cosine, and then looking at the integral of 1 on x. And then finally, we'll finish with the integral of exponentials a to the power of x and e to the power of x. Okay, so if we start with our rule for general polynomials and power functions. So the general rule here is that the integral of x to the power of n with respect to x will be x to the power of n plus 1. So we add 1 to the power and we divide by the new power. And we don't forget Charlie. So we always have that plus c. That's our general rule. If there is if we look at it in the form ax plus b to the power of n, so where this is linear and the derivative is a constant, then we can still integrate this in the same way. The only difference is it will be 1 on ax plus b to the power of n plus 1 over n plus 1, and then plus c. So you could look at that as ax plus b to the power of n plus 1 over a multiplied by n plus 1 plus c. Okay, so that's what we're going to look at for general polynomials. Relatively straightforward. It works the same whether we have integer values for n or we have rational indices, so square root functions or any of those radical functions, as well as negative indices. The second general rules we're looking at are trig functions or trigonometric functions. Specifically, we're looking at the integral of sine x with respect to x. So if we remember that the derivative of sine x is cos x, the integral will be negative. It will be negative cos x plus c. And so then if we look at it having a linear internal function, so sine of ax plus b with respect to x, it will be negative 1 on a cos ax plus b plus c. And if we look at cosine, then we've got integral of cos x dot dx will be sine x plus c, and the integral of cos ax plus b with respect to x will be 1 on a sine ax plus b plus c. When we look at the 1 on x or derivative over the original function, I like to call these the special quotient rule. So if we have integral of 1 on x dot dx, as 1 is the derivative of x, it's simply going to be the natural logarithm of x plus c. And probably more useful for us is that if we have the integral of the derivative of a function over the original function dot dx, it will be the natural logarithm of that original function plus c. Okay, so that becomes very useful. And it will pop up a lot, particularly when we get to partial fractions and more complex integrals. Okay, so the final ones we're looking at are exponentials, and these will be pretty straightforward. So we're looking at the integral of e to the power of x dot dx. Now, this one is important because we know that the rate of change of an exponential function is itself. So when we reverse that and we look at the integral, it will simply be e to the power of x plus c. When we throw in that linear factor again, this time in the power, so e to the power of ax plus b dot dx, it will be 1 on a e to the power of ax plus b plus c. So it only differs by the coefficient of that linear term. Okay, so rather than using a, I'm going to use n. So we're going to look at the integral of n to the power of x dot dx. So the only difference here is because the base is not Euler's number, it will differ by a factor of ln n. So it will be 1 over ln n, n to the power of x plus c. Or if you prefer, n to the power of x over ln n plus c. Now if we throw in that linear power again, n to the power of ax plus b dot dx, we've got 1 over the derivative of this power, which is a ln n, and then multiplied by n to the power of ax plus b, and don't forget Charlie. Now we could also write that as n to the power of ax plus b over a ln n plus c. Okay, so that's all the general rules we'll need to know. I'm hoping that you can see probably the important ones to remember are the first ones, and then when we apply that linear function in as the internal function, it's always just going to be dividing by the derivative of that function. So if you think of a chain rule, and we'll do this over here, the chain rule is simply if we're looking at the derivative of f of g of x, then our whole approach is that it's going to be the derivative of the internal function multiplied by the derivative of the external function while keeping the brackets the same. So if when we find the derivative we're multiplying by the derivative of the internal function, when we're reversing that chain and we're doing these simple integrals, then when we find the integral of f of g of x with respect to x, it's going to be 1 over this derivative and then multiplied by that primitive of the original function. And don't forget Charlie. Now, we just have to keep in mind that this is only when g of x is in that form ax plus b. So only when it's a linear function, because the derivative of that will be a constant. If we start throwing extra variables into there, they have to cancel out before we can apply this skill, and that will be substitution method. We'll look at that in the next few lessons. Okay, so that concludes this lesson. This is just a review of the basic integrals you should already know. We'll apply that and we'll look at a couple of examples in the next lesson.